Now, in this video, we are going to take up one more problem. The problem number 30. A horizontal beam CD of 10 meter long, carries a UDL of 1600 Newton per meter. So 1600 Newton per meter together with a concentrated load of 4000 Newton at the left end C. The beam is supported at a point capital A. The beam is supported at a point capital A, which is 1 meter from C. From C, it is 1 meter. And at B, which is on the right side half of the beam, half of the beam. That means it is from 5 meters from the midpoint beam and X meters from end C, from X meters from end D. Determine the value of X. We need to find out what is the value of X if the midpoint is the point of contrafracture. That means in the bending moment at that particular point where it will going to change its sign. For this arrangement, draw the SFD and BMD. So this is the condition given. So first, suppose we want to find out the support reactions. Resolving the forces vertically. So what happens? Upward reactions is equal to the downward reactions. RAV plus RBV will be equal to 4000 plus 1600 into 10. So on simplification, RAV plus RBV will be equal to 20,000 Newton. Therefore, since the midpoint E of the beam is the point of contrafracture, therefore bending moment at the point E will be equal to 0. So taking the moments about the point E, considering from the left side support. So taking the moment about the point E, that is at the midpoint, considering the left side of the forces, that means you have the RAV and UDL up to 5 meters and 4000 Newton. So minus 4000 into 5 minus RAV into 4, because 5 minus 1 will be equal to 4, which will be minus 1600 into 5 into 5 by 2, because the point of contrafracture is at the midpoint. So taking only the left hand side support. So that will be equal to 0. So on simplification, RAV will be equal to 10,000 Newton. So RAV will be equal to 10,000 Newton. Now, what will going to be the value of RBV? RBV will be equal to, so the sum of these forces which we have calculated is 20,000 minus 10,000, which will be equal to 1,000 Newton, 10,000 Newton. Now, taking the moments about E, considering the right side supports, we need to consider the right side support because we need to find out what is the distance between B and D now. So to find out that, minus 1600 into 5 by 2 plus RBV into 5 minus X is equal to 0. So we know 1000 on simplification, minus 20,000 plus 10,000 into 5 minus X. So therefore the value of X will be equal to 3 meters. So the distance between B and D will be equal to 3 meters. Hence the right side support is 3 meters from D. So this is how you will be able to calculate the values. Now we will go for the shear force diagram. So SF at C will be equal to minus 4000 Newton. Then SF at A will be equal to minus 4000 minus 1600 into 1. So that will be between C and A, that is the value. Once you are considering that, so then at the point A, because due to the vertical load which is acting at the point A, which is acting upwards, will be equal to plus 10,000, which will be equal to plus 4,400 Newton. SF at just on the left hand side of B. So that means SF at B will be equal to plus 4,400 minus 1,600 into, so this is 3 meters and this is 1 meter. It will going to be 4 meters. 10 minus 4 will be equal to 6. So minus 1,600 into 6 plus 10,000. Between A and B, it will be the value, it is plus 4,400 minus 1,600 into 6. whatever the value you will going to get, that will be the value between shear force between A and B. At the point B, because due to the load acting upwards is positive, it will be plus 10,000 kilonewton. Therefore, you will going to get it as 4,800 Newton. SF at D. SF at between B and D will be, which will be plus 4,800 minus 1,600 into 3, which will become 0. So this is how you will be able to get the shear force diagram. So SF at C will be equal to 4,000 Newton. SF between C and A will be minus 4,000 in minus 4,000 minus 1,600 into 1. So it varies to 5,600 between 4,000 minus 4,000 Newton to minus 5,600 Newton. It will drops down the shear force because due to the point load at the point A, which is of 10,000. So it increases from minus 5,600 to plus 4,400. Between A and B, plus 4,400 minus 1,600 into 6, which comes to minus 5,200. And because due to the load at the point B, which is acting upwards, it is 10,000. So plus 10,000. The SF increases from 5,200 to plus 4,800. So because due to the point load at the point B, which is acting upwards, and between B and D, which is plus 4,800 minus 1,600 into 3, which will be equal to 0. The line joining between these two, it becomes. Since it is a UDL at every point, so naturally the variation of curves will going to be a linear one. So that is what we have explained here. SF varies. This is 5,000 linearly due to UDL, and then changes suddenly to plus 4,000 due to the support reaction. So all those which we have been already explained here. So then the next point will going to be the bending moment diagram. So what will going to be the bending moment at the point C? The bending moment at the point C is 0. BM at A will be equal to minus 4,000 into 1 minus 1,600 into 1 into 1 by 2 will be equal to minus 4,800 Newton meter. Then BM at B will be equal to minus 4,000 into 7 minus 10,000 into 6 minus 1,600 into 6 into 6, minus 1,600 into BM at B will be equal to minus 1,600 into 7 by 2 because the UDL is for the entire section. So that will be equal to minus 7,200 Newton meter. BM at D will be equal to minus 4,000 into 10 minus plus 10,000 into 9. 10,000 into 9 minus 1,600 into 10 by 2 plus 10,000 into 3, which will be equal to 0. So this is how you will be able to get this bending moment diagram. BM at C is 0. BM at A will be equal to minus 4,800 Newton meter. Since it is a UDL, it changes parabolically from 0 to minus 4,800 Newton meter. And then from here, BM at B will be equal to minus 7,200 Newton meter. And at BM at D will be equal to 0. But we cannot draw this until you will going to get the bending moment, maximum bending moment at the point. So in order to get the maximum bending moment at the point, where the bending moment will going to be maximum only when the shear force changes its sign. So the maximum bending moment will be at the points which is A, which is E, and which is F. So B, which will going to be A, E, and B, where you will going to get the maximum bending moment. So A, E, and B. So to do that, let F be the distance of x meters from E, where you will going to get the shear force, where maximum bending moment at that point. Let F be x meters from C. So therefore, SF at F will be equal to 0. So that means minus 4,000 minus 1,600 into x plus 10,000 will be equal to 0. So therefore, x will going to be 3.75 meters from C. Therefore, BM at F will be equal to, again that will be equal to 0. So minus 4,000 into x minus 1,600 into x by 2 plus 10,000 into x minus 1. So the value of x what we have is 3.75 meters. Therefore, substitute the value of x as 3.75 meters in the equation. Here we are not written the x equation, but we have directed, we have straightly substituted the value minus 4,000 into 3.75 minus 1,600 into 3.75 into 3.75 by 2 plus 10,000 into 3.75 minus 1 will be equal to, that is the value on simplification, you will going to get it as 1,250 Newton meter. So you will going to get the point where you will going to have 1,250 Newton meter. Then what happens? So from A, which is at minus 4,800 Newton meter, it joins up, it goes to the positive side and it comes to the maximum bending moment of 1,250 Newton meter. And from then here again it drops down to the negative value of minus 7,200 Newton meter. Therefore, the bending moment will going to change its sign at the point G and also at E. So now what will going to be the maximum positive bending moment is at the point F, which will going to be 1,250 Newton meter plus. Now maximum negative bending moment will going to be minus 7,200 Newton meter, which is at the point B. Now we will going to get the point of contrafracture. What is the point of contrafracture? Where the bending moment changes its sign from positive to negative. Let the point of contrafracture be G at y meters from C. So that is at this point is y meters from C. So then what will going to be that value? So BM at G, where the bending moment changes its sign, naturally the value of bending moment at the point G will be equal to 0. So that will be equal to minus 4,000 into y plus 10,000 into y minus 1 minus 1,600 into y by 2. So that will be equal to 0. So y square minus 7.5 y plus 12.5 will be equal to 0. So on simplification, y will be equal to 7.5 plus r minus root of 7.5 square minus 4 into 1 into 12.5 divided by 2 into 1. So that will be equal to 2.5 meters or 5 meters. Therefore, hence the points of contrafractures are 2.5 meters from G, 2.5 meters, that is point G from C, and 5 meters from the point E, where you are going to have the maximum respectively from the end C. So 2.5 meters from point G and 5 meters, that is at point E, that is respectively from the end point C. So that is from here to here, it is 5 meters. So this is how you will be able to analyze and solve the a beam of overhanging beam having 1,600 kilonewton per meter of uniformly distributed load along with a 4,000 Newton of point load for a span of 10 meters. Thank you.